Preston. Wonderful, wonderful. All right, I'm going to jump right in. So today's topic is using unplugged coding to introduce robotics. So what type of code projects do you do in your class or plan to do? Lori says, we use lots of different robotics programs. Wonderful. So probably some driving around anytime you're working with robots or making them move in some way, depending on the shape of the robot. Emily says students create their own games on Codable. Rasim says he uses Lego Mindstorms for his coding. Awesome. So we've got a lot of different things too. Preston says he does things with Scratch and exploring on there. So yeah, lots of different types of on computer and with robotics type code in your classes. Perfect. So what is unplugged coding? If you are unfamiliar with this term, unplugged coding is simply a method of teaching computer programming concepts without using the computers. So you can be using physical activities, writing, lots of different methods to sort of work out the logistics and the fundamentals of the code on paper or with blocks or things like that before you ever even power on your robot or power on your computers. So this can be done for both robotics as well as web development, app development. So for the people who are creating games and things like that, unplugged coding can definitely be used for you as well. From my own experience, I was recently programming a website, not publicly hosted, but just one to enhance a board game that my boyfriend and I played together. So we were building this whole web app, and we broke out some of the unplugged coding that I'm going to go through today, namely pseudocode, which is one of the ones we'll get to later. So big fan of this in my own life as well as in an education environment. So before I jump too far into the different types of unplugged coding there are, I'd like to hear again from you with what do you think are some of the benefits of doing this unplugged, pre-computer, pre-robot type of coding? What have you either seen or think you might see when you start doing things low tech? And what are the benefits of that? Approachable for all, help students to look at each other, get students to look at each other, yes. I definitely love that it's approachable. It is a lot less intimidating. It's also more accessible for if you're doing anything with students who don't have necessarily Wi-Fi at home, you could do unplugged programming activities any environment. Emily says it helps the students really create the direction step by step by taking away those distractions of technology and really just focusing on the code. Evan here says it makes it more collaborative. Yes. Rasim, learning the fundamentals of programming. Crystal, better understanding for kids who are new to coding. Yes, I always start with unplugged coding anytime I do even teacher professional developments. All right, there are so many things I'm loving this. So here are some of the benefits I came up with, and I can see that a lot of these have already been brought up by you all. So we are all on the same pages. There are so many good things. Preston said he loves doing the code the teacher to make a PB&J sandwich. I did that one as a student. I remember that activity, really thinking about every step-by-step instruction. Jonathan adds, develops critical thinking skills related to coding. Yes, for sure. So any environment, low cost, it's a break from screen time. I didn't hear anyone say that, but especially if you're in a computer science or programming course, that unplugged, that lack of screen time is really nice to break up all the tech heavy parts of a class like that. And then everything else you all did mentioned on here, other than it saves your robot battery. If they can do the planning on paper, then when they get the robot turned on, they can fly through the programming part a lot faster, thus allowing you to do more with your battery, because I don't know how many people here have wanted to do more with their code and then their battery ran out partway through, especially if you're doing multiple classes in a day. Let's see. It's understanding processes and executive functions in their own lives, simplifying tasks, breaking them down into sub pieces. Yeah, that's a great life skill beyond just coding as well. So Crystal says allowing students to collaborate more freely. Yeah, it's a lot less intimidating. They're not worried about getting it wrong so much as figuring it out. And that's a big, nice shift I see anytime I start doing programming. So I'm going to launch a poll here and to see what unplugged coding methods you may have already done in your class, or other ones you have tried either in personal life or in your class. And if you answer the quiz here, or the poll, I should say, lots of folks have said they've used physical code blocks or acting it out. Physical code blocks is currently winning, but it is neck and neck with acting it out. About half of you have said you've done the verbal brainstorming of a code, and then a smaller percentage have done sort of pseudocode or writing out the code. Oh, verbal brainstorming has tied physical code blocks and acting it out. I love it. Can I explain verbal brainstorming? Yeah, that is actually the first section that I'm going to get into. So I'm going to end the poll now and jump right into these sort of 4 categories that I put together. So verbal brainstorming. This particularly is things like, the way I would do a verbal brainstorming is, let's say you are doing a route-based code and you're sitting there looking at it and the students are saying, okay, we want it to go straight for like 2 blocks and then turn right and go 1 block. And then maybe it does something here like, okay, we have to turn on a light or change the screen. Or if we want it to drive and then when it sees this color, it needs to stop and do a U-turn because that's a do not enter sign or whatever it is. They're really trying to sit there and figure out what the goal is. I wouldn't say this is the whole unplugged coding, but it's often a place where it can start. And as they're working together and communicating, it's building these sort of softer skills. So that communication, that teamwork, as they figure out sort of how they want to approach creating the code. And then tying in with this, which leads into pseudocode later, is taking notes. So this is more optional from the verbal standpoint, but making that plan and focusing more on talking it out. But what I love as an educator is using this as a formative assessment moment for my students. I know last week when we were in our learning lab, we were talking about design engineering mindset, and someone mentioned the 5 whys. Why are you doing this? Why are you doing this? You can use that same approach here. These are some questions I put up that I might ask as a teacher. So what is the goal of your program? Get them to explain it to you. What problems do you think you might run into? How can you break this down into bite-sized pieces? Where do you think it might go wrong? Have you considered a different approach? And just really get them to start thinking deeply and critically about all of the different things. And the questions you ask will obviously vary based on the level of your students, age, as well as programming levels. So students who are maybe building full-powered JavaScript, HTML, Python, big codes, you're going to ask them a little bit more in-depth questions than you are with students who are just starting to learn how you build a program, how you do something, maybe using pictures to control a robot or control a simple game. So these are just samples, but they give you sort of a concept of how you can use verbal brainstorming as a moment for formative assessment, understand what your students are getting and what they're struggling with. Love the question where things could go wrong. Yes, things can and will go wrong anytime you code, which is one of the best educational moments for students, is that failing forward. We talk about that a lot at Boxlight. So really to prepare the students for things might not work on the first try and work through some of those problems before you ever turn on your computer. The next one, which a lot of people said they had done, was physical code blocks. So We have on our My STEM Kits website, for anyone who's got an account there, we have our coding kit. And that's these little 2D or 3D printable, I have the 3D ones in front of me today, little blocks that directly match our picture-based interface for our specific MyBot Recruit or MyBot Fusion. And these allow the students, you can see in the picture I have here of the young student, they're trying to figure out how you would program I think it's a 5x1 rectangle. That's the challenge they're doing. So you see how they're actually starting to lay out for the route, it physically in the route. You go here and then you go here and then you turn and the route's turning with it. And then once they figure out the order of it, they can actually rearrange the blocks into what it looks like in a coding interface, how it starts at the top and goes down one at a time. So we have a few different lesson plans we do with this. Rectangle routes is one of them. That's the one they're doing here. And then another one is rectangle routes is actually the best at this concept. And even if you have older students, that's written for K through 2, but older students, this is still a good introduction to how you build a code. But instead of focusing on the math of length and width and what these things mean from a geometry side of things, if you have older students, focus on, this is a quick, get your feet wet type of challenge where you're, figuring out how you build a rectangle, have your robot program it. It's one I use again during professional development trainings all the time with teachers, just to have that first moment of success. Start with something simple and build up from there. But starting with either 2D printable or 3D printable blocks can help build that out. Now, we don't just have this for our picture-based environment. You can see in the other picture over here, we also have it for our Scratch similar environment, our Blockly based interface. So you can do much more intense programs using those blocks as well. But the nice thing about this style is that they make it really easy for the students to translate from the Unplugged to the official coding interface because they're in the exact same style as the interface is. And if, like me, you're a color motivated person, you can color code them when you print them or paint them afterwards to match the colors in the interface. This is another one that I came up with, and it is index cards. So if you have a code specifically on like route following and things like this, students can create their own little index cards with instructions, and you figure out what step comes one after another, and you can do either individual arrows on one card or the little like multiplication sign next to it if they're familiar with multiply. So go forward 3 times. Sorry, I'm working with a mirror reflection here. I notice my finger keeps going the wrong way. Or maybe you just keep it simple and just have them do one at a time. And they can build this little thing. I'm just using a simple O-ring style binder here and just used crayon, and they made their own for whatever route they were doing. Emily and Chrissy are both saying this is great for littles. Yes, this is perfect for your littles. Maybe would be a little bit, I'm not sure the high schoolers would love this, but again, if they've never done code, who doesn't like playing with crayons? And then integrating these physical codes with writing. So this is my transition into pseudocode, but you can see different ways to do it. So even with the picture blocks, you could have either the multiplication or backwards 2 times, forward 3 times, or they can just start stacking them down. You notice I'm using a whiteboard here. I love having a whiteboard because it's not intimidating if you have to change things. The same with the blocks, you can simply slide them around. You can quickly erase with your finger, rewrite, make adjustments on the fly, and students don't have to feel bad about like, oh no, I wrote it in pen, now I have this big ugly scratched out thing. Jonathan here says he did the index card type thing with his AP computer science kids who were seniors in high school, and they thought it was silly at first, but it really helped them understand. Exactly, you got to get past that silly thing. But all of these are really good at laying that foundation. So you didn't know I was going to quiz you, but reading code And reading what other people have written is a really good way to start understanding how codes get built. If you ask any web developers out there, anyone who uses Python languages, anything like that, they're probably looking back at other code examples. So, can anyone here figure out what my more advanced Blockly code is doing? If you're having a hard time seeing on the screen, if there's not enough resolution, I'll read through it while you're typing it in the chat, hopefully. But it says, create something called side counter, set side counter to 1, repeat 4 times, and I'll give you a hint if you're not familiar with Scratch, that it's everything inside this repeat is what's going to repeat. And then it says, drive at 50 for 1 second, also translating my handwriting, rotate at 30 for 1 second, print side plus side counter, set side counter plus 1. So basic terms, can anyone figure out what my written out blocks plus pseudo code program is doing roughly? Now I got this a little complicated because I have variables in here. Someone says, is it driving in a circle? Someone says it's dancing 4 times. Okay, you're very close. It is doing a route, but it is driving, sorry. It is actually driving in a square. These values are theoretically representative of like drive at speed 50 for a second and then rotate something enough to do like a 90-degree turn. I don't know exactly how, whatever speed it would have to be. So these are placeholder values, but yeah, that makes more sense. I love it. Okay. So this leads us into pseudocode because I sort of combined blocks with pseudocode in that last example. So this is a human readable, informal representation of a computer program used for planning and communication. You're not worried about the syntax. You're not worried about getting everything perfectly right in the computer language. For anyone who's used Python, or even a lot of programming languages, that proverbial you missed a semicolon, you don't have to worry about that in pseudocode. So a pseudocode example of that last program I did would be goal. All right, set my goal. I want to drive in a square and print the side number each time I change sides. So I'm going to need a variable called side counter. What menus will we use? So I know I need to drive, and I know I need to like rotate, and I'm going to do repeats because I need it to go in a square. And I want it to tell me something, so I'm going to have a text in there as well. And maybe that's all they come up with at first, but I've given you a hint here that when I did my first pseudocode and was started to read through it, I realized I missed some. I missed that I would need the menu of variables. That's where I'm going to set that variable. And I missed math, which is how I would get the numbers to set the variable. So this is where I never pulled up my computer. I never made this actual program. I figured out my own errors as I was writing this pseudocode. So it's a perfect chance for your students to do the same thing, especially once they start having their teammates, their peers, check their pseudocode, check their unplugged programming. So here's a different, like a continuation. That was sort of like the planning. Here's more of a traditional pseudocode. And you can see this is exactly what I was reading off my image. Now, I know we're running short on time, so I'm not going to make you all answer the question I had in here, which was talking about more troubleshooting. One line of my code is in the wrong spot. Now, if any of you can figure out which line needs to move before I change slides, bonus points to you. But I won't give you too long to answer that because I want to respect your time. But as I was figuring this out, I realized I should have put one of my items of code, my lines, earlier than it was. And that item was to print the side and side counter before I drive the side. That way the robot is returning 1 when it's driving on side 1 instead of driving side 1, saying 1 and then starting to drive side 2. So now I have 1 coming at the beginning while it's driving side 1. It'll switch to 2, drive side 2, and so forth. Okay, one comment here is that students sometimes have a hard time understanding how to do peer review and peer editing. One of the ways I like to do that is actually acting it out, seeing if they can break the other one's code by following it, very much like you might do with that PB&J thing. So put it to the test, assume it's right, follow its instructions and see if you get the expectation you want. And then learning, just like you do in writing, how you can highlight things that are working, then things that might need improvement, or getting them to ask each other those same questions you ask as a teacher. So then here's my aside is for other types of code and general coding, like infrastructure knowledge, we do also have these stencils. And you can do both logic gates and flowcharts, whether or not you have these 3D printed stencils. But those are also in my STEM kit. So this is part of pseudocode and part of writing, but I didn't want to spend too much time on it. So I just threw one slide in here for you. But to continue with that question, I mentioned acting it out as one of the ways to troubleshoot. You can either be the robot. So you see there are code blocks here on big pieces of paper where the students are walking along. That's a good way to do the troubleshooting. That's a good way to figure it out. You can also move the robot itself rather than being it yourself. So follow it along the path, follow it what it's supposed to do. If it's not just route thing, it would be things like, okay, I'm driving along until I see red. Oh, I see red. I'm going to stop. Okay, what happens when I see red? Oh, I'm supposed to back up, change directions, and they're moving the robot through and trying to really think through each line of code. And then tying this in with some of your other code methods, back to these lovely index cards, you have your start that you have ready to go, you trade with another student, you give them your set of index cards on the loop, they follow it through, see if it works out, and make any adjustments as necessary. So if you happen to have anywhere in your school square tiles, this is the perfect way to do route following, because it can simply be like how many blocks turn. Maybe you add extra challenges like avoiding certain colors if you have multiple colors of your tiles. May not be in your classroom, but oftentimes hallways or cafeterias will have this type of a flooring, which is really good for this acting it out type of pseudocode. All right. Throw in the chat which of the methods discussed you are most excited or interested to try out. Or if you have other suggestions, feel free to throw those in there as well. But I'd love to hear which of these sound most interesting to you as educators. And while you're doing that, quick promo for next week. Evan is going to be continuing the design thinking that we had last week and talking about ways you can use 3D printing and robotics to sort of put it in your class as more instructional. All right, Q&A time. And Lori says, students code their partner from their desk to the door using the squares on the floor. Perfect, yes. That's a great way to do it. Love that. Someone says, I love the stencil idea. Good way to keep things tactile. Yes, all of these are about hands-on, interactive preparations. Chris here says pseudocode sounds like something I use all the time. I love this as a life lesson. Yeah, this is not just for computer science. This is far more than that. And then I'm going to just quickly drop the link in the chat here for anyone who has not signed up for next week's or any of our future sessions. We have a whole series of these. We're doing them every week. We even have some guest speakers coming up. So check the schedule at that link. And if any of you did not have my STEM Kits accounts, because I referenced that a few times through here, that's where all of our lesson plans live. That's where these code blocks live. That's where you can find lessons for our robotics solution. You can go to mystemkits.com and register for a free trial to get access to those things as well. So, okay, open Q&A, everybody. I know I ran a little longer, was closer to 25 minutes today, but we had such good conversation that it was totally worth it. Hopefully you agree. All right, I think I caught all the questions in the chat as they were coming through. Awesome. Well, thank you all for attending. I'll stick on another minute or two in case anyone is typing a question, but I appreciate you joining today. Have a great rest of your week.